daily life, you make hundreds of decisions without even realizing it. Should I study now or later? If it's raining, I'll take an umbrella. If I score above 90%, I'll get a new phone. These are all conditions and actions. Programming is no different. We need to teach our computers how to make these choices based on different situations. This ability to decide is what makes our code smart, interactive, and powerful. Without it, our programs would just be a dumb list of instructions, executing one after another with no intelligence. So, how do we give this power to our code? We use special tools called control statements. These statements, like if, else, and switch, are the magic wands of a programmer. They allow a program to check a condition and then decide which path to take. Imagine you're building a simple game. You need to check if the player's score has reached 100 points. If it has, you display a "You win" message. This simple check is a decision. The program needs to evaluate the situation, the score, and act accordingly. This is the very essence of creating dynamic and responsive applications that can handle various inputs and scenarios. This entire concept revolves around asking questions that have a yes or no answer, or in programming terms, true or false. Is the user's age greater than 18? True or false? Is the entered password correct? True or false? The ability to evaluate these simple true or false questions is the first step towards building complex logic. Throughout this journey, we will explore exactly how to frame these questions using operators, and then how to tell the computer what to do based on the answer it gets. This foundational skill is crucial, whether you're building a website, a mobile app, or even working on artificial intelligence. Every single piece of intelligent software you have ever used is built upon these fundamental principles of decision-making. So get ready to learn the art of controlling the flow of your program. We will start with the very basics, the operators that help us compare things, and then slowly build up to more complex structures. By the end, you'll understand how to create code that can adapt, react, and make choices, just like a human mind. This isn't just about learning syntax. It's about learning how to think logically and structure your thoughts into a functional piece of code. This skill will not only make you a better programmer, but also a better problem solver in general. Let's begin this exciting journey into the world of conditional logic and make our code come alive with intelligence. Before we can make decisions, we need to know how to compare things. In programming, we use relational operators for this. Think of them as the mathematical symbols you already know, but for coding. For example, to check if your marks are greater than your friends', you'd use the greater than symbol. If you want to check if your marks are exactly equal to 95, you use the double equals sign. Notice it's double equals and not a single equals, because a single equals is used for assigning a value, not for comparing. We also have less than, greater than or equal to, less than or equal to, and not equal to. These operators are our primary tools for creating conditions. Now, let's take a simple example. Suppose the passing marks for an exam are 40. We need our program to check if a student has passed. We can create a condition like student marks greater than or equal to 40. The computer will look at the value stored in student marks and compare it to 40. If the marks are 45, the condition 45 greater than or equal to 40 becomes true. If the marks are 35, the condition 35 greater than or equal to 40 becomes false. This simple true or false outcome is what our decision-making statements, which we'll see next, will use to choose their path. These relational operators are the absolute foundation, allowing us to ask the basic questions upon which all complex logic is built. Sometimes one condition is not enough. What if you need to check two things at once? For instance, to get into a top college, you need more than 95% marks, and you need to have above 90 in a specific subject. This is where logical operators come in. The three main ones are and, or, and not. The AND operator returns true only if all the conditions connected by it are true. So marks greater than 95 and subject score greater than 90 would only be true if both things are satisfied. If even one is false, the whole thing becomes false and you don't get admission. It's a strict operator. The OR operator is more relaxed. It returns true if at least one of the conditions is true. Imagine a discount offer. You get a discount if it's a weekend or if you have a special coupon. So, is weekend true or has coupon true would be true if it's Saturday, even without a coupon, or if you have a coupon, even on a weekday. You don't need both. Finally, the NOT operator simply reverses the result. It turns a true into a false and a false into a true. For example, not is raining would be true if it is not raining. These logical operators allow us to chain multiple simple questions together to form highly specific and complex conditions for our programs. Now that we know how to create conditions, let's learn how to act on them. The simplest decision-making statement is the if statement. It's like saying, if this condition is true, then do this work. It's a one-way street. For example, let's say you're coding a login system. You can write, if password equals correct password, then print login successful. The code inside the curly braces will only run if the condition inside the parentheses is true. If the password is wrong, the condition is false, and the program simply skips that block of code and moves on. Nothing else happens. The if statement is perfect for situations where you only need to take action for a single, specific outcome. But what if you want to do something when the condition is false? That's where if-else comes in. It provides an alternative path. It says, if this condition is true, do this. Otherwise, do that. Let's improve our login example. If password equals correct password, then print login successful, else print incorrect password. Try again. Now, our program is more helpful. It gives a success message for a correct password and an error message for an incorrect one. It handles both possibilities. The else block provides a default action to be taken when the if condition fails, ensuring that the program always has a clear instruction to follow, leaving no ambiguity. Sometimes, life gives you more than two choices. What if you want to check multiple conditions? For this, we use the if-else ladder, also known as the if-else ladder. This structure lets you check a series of conditions one by one. Imagine a program that gives grades based on marks. You could write it like this. If marks are greater than or equal to 90, print grade A. Else if marks are greater than or equal to 80, print grade B. Else if marks are greater than or equal to 70, print grade C. Else print grade D. The program checks the first if. If it's true, it prints grade A and skips the rest. If it's false, it moves to the first else if and checks that. It continues down the ladder until it finds a true condition or reaches the final else block, which acts as a catch-all for all other cases. Within any of these blocks, you can place another if-else statement. This is called nested if-else. It's like a decision within a decision. For instance, after a successful login, if login's successful, you might want to check the user's role. If user role equals admin, then show admin dashboard, else show user dashboard. Here, the check for the user's role is nested inside the check for a successful login. This allows for very detailed and layered logic, where one condition must be met before another is even considered. Nesting helps you handle complex scenarios where the outcome depends on a sequence of evaluations, making your program's logic more refined and precise. While the if-else ladder is powerful, it can sometimes look clumsy and be hard to read, especially when you are checking the same variable against many different specific values. This is where the switch statement comes in as a cleaner, more elegant alternative. Think of a switch statement like a menu at a restaurant. You look at the menu, the variable, and choose option 1 for a burger, option 2 for a pizza, or option 3 for a salad. The switch statement works similarly. It takes a variable, and compares its value against a list of cases. When it finds a matching case, it executes the code associated with that case. Let's see an example. Suppose you have a variable day equals 3, and you want to print the name of the day. Using a switch statement would look like this. Switch day, case 1, print Monday, break. Case 2, print Tuesday, break. Case 3, print Wednesday, break. Default, print invalid day. The program evaluates day, sees it's 3, jumps directly to case 3, and prints Wednesday. The break keyword is crucial. It tells the program to exit the switch block after the case is executed. Without it, the program would fall through and execute the code for all the subsequent cases as well. The default case is like the else block. It runs if no other case matches. So, when should you use an if-else ladder, and when should you use a switch statement? The general rule is this: use an if-else ladder when you are dealing with a range of values or complex logical conditions. For example, checking marks greater than or equal to 90, or age greater than 18, and is citizen true. These kinds of relational and logical checks are the perfect job for if-else. On the other hand, a switch statement is ideal when you are checking a single variable or expression against a list of discrete constant values, like numbers 1, 2, 3, or characters A, B, C. It makes the code more readable and often more efficient in these specific scenarios. In conclusion, mastering decision-making statements like if, else, and switch is absolutely fundamental to programming. They are the tools that elevate your code from a simple script to an intelligent, interactive application. They give your program a brain, allowing it to analyze situations and react in different ways based on the input it receives. Whether it's validating user input, controlling a game character, or processing complex business logic, these control structures are working behind the scenes. By understanding how to use them and when to choose one over the other, you unlock the power to build truly dynamic and useful software. Keep practicing, and soon you'll be able to tell your computer exactly how to